So we're going to talk about the right triangle, which is a triangle with the right angle that shows the 90 degrees. Then talk about the ratios between the angles, and what it means by angle is we're going to talk about the special angles that we generally use to apply to right triangle ratio, which are 30 degrees, 45 degrees, and 60 degrees, and the ratio between the angles as well as sides. And our ultimate goal is to define the sine theta, cosine theta, as well as the tangent theta, which are the three basic trig values that will help us define the trigonometry using our right triangle ratios, and think about the technique how to memorize or define the sine theta, cosine theta, as well as tangent theta. So in order to think about the right triangle ratio, which is a proportion between the angle measurement and size, let's start off by thinking a right triangle with the main angle as 45 degrees. And we can realize that if the main angle is 45 degrees, we can convert them in terms of radian as pi/4 radian. And from now on, I will express every single radian measure, the angle, in terms of radian, because if you're not familiar with the radian concept, we won't be able to solve the trigonometric function questions. So if you're not familiar with the radian, you need to go back to my previous video about introduction to the radians and think about the concept more. So again, if the main angle is given as pi/4, then we could realize that if one angle is pi/4, then the another angle will also become pi/4 when this is a right triangle with the right angle that shows that it is in 90 degrees. And the reason is because we know that according to the property of total angle measurement inside the right triangle, these three angle measurements must add up to 180 degrees. If one angle is 90 degrees and another is 45 degrees, then another must always be 45 degrees to satisfy the triangle property. Then we can realize that the two angle measurements are exactly equivalent together, so that means we can apply the isosceles triangle property, where the two sides of a right triangle, in an isosceles triangle except for the hypotenuse, they will be exactly equivalent together along with the angle measurements. So we can realize that the side that is opposite with our main angle, when the main angle is pi/4 radian, we define the ratio that is opposite with our pi/4 radian as square root of 2 over 2. And again, this is a ratio, not an exact value. And the side that is adjacent with our pi/4, and if it's adjacent with our pi/4, another way to say opposite with the other leftover angle, we define its ratio as square root of 2 over 2, which is an exactly equivalent value with the value that is opposite with our main angle. And we could figure out that because of the property of our isosceles triangle. And lastly, the largest or the longest side that is opposite with our right angle, which we call it as the hypotenuse, inside our right triangle ratio, we always call that ratio as a positive 1. So the hypotenuse will always be equal to 1, the opposite side will be square root of 2 over 2, and the side that is adjacent with our main angle pi/4 will be square root of 2 over 2. But this is not what we are interested in trigonometry. We want to solve firstly the three trig values, the sine of our main angle pi/4 in this case. Secondly, we want to solve the cosine of our main angle pi/4 radian. And lastly, we want to solve the tangent of our main angle pi/4 radian, 45 degrees, using this right triangle with the main angle of 45 degrees. So firstly, let's think about the technique to define the sine of our main angle pi/4. And for defining the sine of any main angle, for sine we will use this initial line that always start off the hypotenuse and as we draw the S for initial line of sine, S will finish at the opposite side of our main angle. And this is S for the sine of the main angle. So when we're dealing with the sine, it is a proportion, so we usually write it in terms of the fractions. And the denominator part will be the value where the initial line start off, and the numerator will be the value where this initial line finish off. Now, as we can see for S, it always starts off the hypotenuse of our right triangle, and we finish drawing as the opposite side of our main angle, so the hypotenuse, which is the value we start off, will be the 1, and the value where we finish off, which is an opposite side of our main angle, will be square root of 2 over 2. And again, if we divide any number by 1, it will give us the value of itself as square root of 2 over 2. So square root of 2 over 2 is the value for the sine of the main angle pi over 4. And again, for sine, we'll use the initial line as S that always starts off the hypotenuse of our right triangle. And as we draw the S, it will go all the way down to the opposite side of our main angle, which is square root of 2 over 2. And this is how we define the sine of the main angle. Now let's go to the next one, which is the next trig value, cosine of our main angle, pi over 4 radians. So just like the sine and the cosine, just like the sine, we will notate the cosine in terms of fraction. So the value that will be notated in the denominator will be the value where we start at, and the numerator value will be the value where we finish at. So for cosine, as we draw its initial line as C, just like the sine, it will always start off the hypotenuse, that will be the denominator value, and will finish at the adjacent side of our main angle as a numerator part. Again, for a cosine value, it will always start off the hypotenuse of our right triangle as a denominator part and finish at the adjacent side, which is a value inside the numerator. So the value in our denominator will be the value as a hypotenuse 1, and the value inside the numerator will be the value as square root of 2 over 2. And if we're dividing some number by itself as 1, it will give our answer just like its value as square root of 2 over 2. And this means the cosine of our main angle, pi over 4, is going to give us square root of 2 over 2, which is a ratio between the hypotenuse and the adjacent side of our main angle as square root of 2 over 2. And again, for drawing the cosine is initial line, it will always start off the hypotenuse of our right triangle and will go all the way down to the value adjacent side with our main angle. That will be the value inside our numerator part. So for the tangent, which is the last value for our trig value of the main angle pi over 4, it is a little bit different with the sine and the cosine, because sine and the cosine was a ratio between the hypotenuse and the two legs, but the tangent is a ratio between these two legs. So let's define the tangent of our main angle pi over 4 using the technique we defined sine and a cosine of our main angle. And also, when we're dealing with the tangent of any angles, we need to know that it is the proportion between the sine and a cosine. So when we're drawing the tangent, we're going to use its initial line as t. That will always start off the adjacent side of our main angle. That will be the denominator part inside fraction, and finish off at the opposite side of our main angle. That will be the numerator part. So again, for tangent, we'll use t as its initial line that always starts off the adjacent side of our main angle. That will be the part in denominator, and finish or stop at the part that is opposite with our main angle pi over 4 radian. In this case, that will be the numerator value. So denominator part will be the value where we start at, which is square root of 2 over 2. and numerator part will be the value where we finish at, which is square root of 2 over 2. Now we have the exactly same values in the numerator and denominator. So if you want to simplify, this is exactly same expression, and we already learned in elementary school where if you're dividing by the fraction, we can multiply that term by its reciprocal as square root 2 over 2 in the numerator times the reciprocal of the denominator part, which is 2 over square root of 2 according to the property for the fraction. 2 and a 2 will cancel out, square root 2 and square root 2 will cancel out, and that will give us the value as positive 1, which means the tangent for our main angle pi over 4 is 1. Again, for a tangent, it always starts off the adjacent side of our main angle. That will be the value in the inside our denominator in the fraction, and finish at the value that is opposite side where our main angle pi over 4 radian. That will be the value in the numerator. So we define all three trig functions: sine, cosine, and a tangent of the main angle pi over 4. So we defined the triangle with the main angle as pi over 4 radian, which is 45 degrees. And next, let's think about the main angle, the triangle, right triangle with the main angle of 30 degrees. And from now on, I'll explain a little bit faster because our focus in this video is to memorize or define how to solve sine, cosine, and tangent of any angle measurement inside right triangle. When inside the right triangle with the right angle, when the main angle as a special angle is 30 degrees, which I'm going to notate in terms of radian form as pi over 6 radians. Then we already wrote the sides and the ratios between the pi over 6 radians. If this is 90 degrees, and if this angle is pi over 6, which is 30 degrees, then according to the property of total angle measurement inside the triangle, then this will automatically be pi over 3 radian, which is 60 degrees. Then when the main angle is pi over 6 radian 30 degrees, we define the hypotenuse, always the ratio as 1, the value that is opposite with our pi over 6 radian as 1 over 2, and the value that is adjacent with our main angle pi over 6, or opposite with our pi over 3 angle as square root of 3 over 2. And what we're actually interested in is all three trig values as the sine of our main angle pi over 6. Second one is the cosine of our main angle as pi over 6. And lastly, the tangent, the ratio between sine and cosine, which is the tangent of our main angle pi over 6. How do we define the sine of any special angle as the main angle pi over 6 in this case? For sine, just like we did here, we use s that always start off the hypotenuse of our right triangle. That will be the per denominator, and we finish at the numerator part, which is the opposite side of our main angle. So that means if we express sine of any angle is pi over 6 in this case, the denominator part is the value where we start at, which is hypotenuse 1, and numerator value will be the value where we finish at, which is the opposite side of our main angle, 1 over 2. And again, if we divide any term by 1, it will give us the value as itself as 1 over 2. Secondly, let's think about how can we define the cosine of pi over 6. And again, just like we did here, where the main angle was pi over 4 radian, the cosine, as we draw C, that always start off the hypotenuse, that will be the value in the fraction denominator, and finish at the value at the pi over 6 adjacent side, square root of 3 over 2 radian. So that means if we express cosine of pi over 6, this will be written in terms of denominator and numerator, where denominator will be positive 1, the value where we start at, and numerator part will be the value of square root of 3 over 2, square root of 3 over 2, that is the adjacent side where the value finish at. So again, if we're dividing any numbers by 1, we will get the answer as itself as square root of 3 over 2. Now lastly, let's think about how to solve the tangent of our mean angle pi over 6. For tangent, it always starts off the adjacent side of our mean angle, which is square root of 3 over 2. That will be the denominator part. And as we draw t along with the right angle, and we finish at the 1 over 2 that is opposite side of our mean angle, that will be the part in the numerator. So if we express the tangent of pi over 6, in denominator, it will be the value where we start at, which is square root of 3 over 2. That is the adjacent side of our mean angle. And the value where we finish at, which is the opposite side of our mean angle, 1 over 2, will be the value in numerator. So if you want to simplify this, again, according to what we learned in elementary school, if we're dividing something with a fraction, we multiply them in their reciprocals, such as 1 over 2, which is the value in numerator, times the reciprocal of the fraction in the denominator as 2 over square root of 3. The 2 is going to cancel out, and all we got is 1 over square root of 3, and 1 over square root of 3 will be the value for the tangent of mean angle pi over 6. And we define the sine, cosine, and tangent of our mean angle pi over 6, which is 30 degrees. Now let's think about the last mean angle at also a special angle at 6 degrees, and I'll also write down the mean angle as well as the size of the ratio first before we start them. Let's deal with the last triangle with the main angle of pi over 3 radian, which is 6 degrees. So if this angle here is pi over 3 radian, which is 6 degrees, then according to the formula or the property for the right triangle, then other angle must be pi over 6 radian, which is 30 degrees. Now if you look at this, we can figure out that this is a flip version for this triangle with the main angle of pi over 6 radian, which is this angle here, and the other left over was pi over 3 radian, which is this angle. However, in this case, the pi over 3 radian has turned into a main angle, and pi over 6 radian has turned to a leftover angle. However, the ratio will exactly be same. The side where the pi over 6 is facing, the opposite side for the pi over 6 should be 1 over 2. So again, in this triangle, the side that is opposite with pi over 6 must be 1 over 2, which satisfied 1 over 2. And the side where the square root pi over 3 radian is facing must be square root of 3 over 2. The side where the pi over 3 is facing must be square root of 3 over 2. And lastly, the side where the right angle is facing should always be a hypotenuse as 1. And the side, in this case, where the right angle is facing is always positive 1. So we can figure out that this triangle with the main angle of pi over 6, 30 degrees, is a flip version for the mean angle with the pi over 3, which is 6 degrees. So using this, we want to find the sine of the pi over 3, the cosine of our mean angle pi over 3, and the tangent of our mean angle as pi over 3. So our mean angle is pi over 3. How did we define the sine of the mean angle pi over 3? Well, for sine, the s as initial line for sine always start off the hypotenuse, which will be the value in the denominator, which is 1 in this case, and finish at the side which is opposite with our mean angle. That will be the part in numerator. So sine of pi over 6, the denominator part will be the value where we start off, which is the hypotenuse as positive 1. So this value will be positive 1. And the value in the numerator will be the value where we finish off, which is going to be square root of 3 over 2. So the numerator part will be the square root of 3 over 2. And whatever the value we're dividing with the 1 will give us the value itself as square root of 3 over 2. Now let's think about the second one, which is the cosine of the mean angle pi over 3. Just like the sine, we're going to deal with the fraction. And for a cosine, you always draw off the hypotenuse of our right triangle, just like the sine of mean angle, that will be the part denominator, and finish at the adjacent side of our mean angle, pi over 3, which is 1 over 2, that will be the part in the numerator. So denominator part will be the hypotenuse as 1, and numerator will be the value as 1 over 2 as the adjacent side of our mean angle. And again, anything divided by 1 will give us the value of 1 over 2. Lastly, when we're dealing with the tangent of the mean angle pi over 3, again, the tangent, we use t as its initial line that always starts off the adjacent side of our mean angle, which is 1 over 2 in the denominator, and finish at the part that is opposite with our mean angle, which is square root of 3 over 2. That will be the part in the numerator. So this will be written as denominator as 1 over 2, and numerator as square root of 3 over 2. And again, if you're dealing with the fraction inside the fraction, we'll always convert them in terms of multiplication, like square root of 3 over 2 times the reciprocal of that fraction, which is 2 over 1. And in here, the 2 we're going to cancel out, and we got square root of 3. And square root of 3 is the ratio between the sine and the cosine, which is 1 over 2 in denominator and square root of 3 over 2 in the numerator. And this is t for defining the tangent of our mean angle, pi over 3. So if you review what we did here, the only special angles we could apply inside the right triangle was 30 degrees, which is pi over 6 radian. 45 degrees, which is pi over 4 radian. And lastly, 60 degrees, which is pi over 3 radian. And using this 3 radian form of the special angle, we define the following values for the sides. The side where pi over 6 was facing, the side where the pi over 6 angle was facing, had the ratio of 1 over 2. So where the pi over 6 is facing had the ratio as 1 over 2 as sides, and the side where the pi over 4 is facing, had the ratio of square root of 2 over 2. Lastly, the side where pi over 3, the pi over 3, which is 6 degree, was facing, had the ratio of square root of 3 over 2. And using these ratios, we could define all 3 trig values, sine, cosine, and tangent. All you have to remember is pi over 6 has the ratio 1 over 2 as sides, pi over 4 as the ratio where it's facing as square root over 2, and pi over 3 has a ratio where it is facing as square root of 3 over 2. And we need to remember that from this small angle, as the angle gets bigger, then the side will also increase. And this is the property, the first property that we need to remember. So if the angle is small, then the size ratio is small. If the size angle is big, then the side angle is big. If from the small angle, as it increased, as the angle amount is increased, then the sides will also increase. So this was the first thing to remember. The second thing to remember is how to memorize. The key point in this video is to memorize the sine, cosine, and tangent. And we always use its initial line. So for sine, it always start off the hypotenuse. For sine, always start off the hypotenuse, which will be the denominator part in the fraction. And as it goes and reach all the way down to the opposite side of our mean angle, which will be the part in the numerator in the fraction. And for cosine, we use c as its initial line. So c always starts off the hypotenuse, which will be the value inside the denominator, and finish all the way down to the value which will be the numerator part, which is the adjacent side for our mean angle. And for tangent, it always starts off the adjacent side for our mean angle, and it goes all the way up to the opposite side of our mean angle, which will be the part in the numerator, and this will be tangent. And this is how we define sine, cosine, and tangent value. All you have to remember is we use its first letter as the initial line for defining those values. So this was the second thing to remember, second key point in this video. And all you have to remember is these two things. And in the next video, where we're going to talk about the pros and cons about applying the right triangle ratio to the actual trigonometric functions, and compare it with the new concept we're going to apply to the trigonometric function, which is called the unit circle.